Hello everyone. Many thanks for joining me. According to this video, a Foucault pendulum proved Earth was rotating. I'm not sure it really proved it. If Earth were rotating and a Foucault pendulum started in a state with zero velocity, it would keep swinging back and forth along the same line. If at its highest point, it has a tiny velocity in a direction perpendicular to the direction to the lowest point on the pendulum, then maybe it would have such a tiny deviation from moving exactly back and forth that a human can't see that tiny deviation with their own eyes. But that deviation would result in a slow precession of the pendulum, and a day is so long that the direction it's swinging in would rotate a significant amount. If you have a system where a particle's acceleration is always equal to its displacement from a certain point multiplied by a negative constant, and it's not moving back and forth in a straight line, it will travel in an ellipse which does not precess at all. I think the same is not true about a Foucault pendulum. Its acceleration doesn't vary linearly with its distance along the sphere of where it can go to the bottom, and the sphere of where it can go doesn't have Euclidean geometry. My question is, can we really conclude from looking at a Foucault pendulum and the laws of physics that Earth is rotating? Maybe if its initial velocity is controlled to be very close to zero, we can tell from its precession that Earth is rotating. Also maybe if its arc is very small, the rate of precession for any deviation from going back and forth that's undetectably small to the human eye will be so much slower than the rotation of Earth that we can tell from watching it that Earth is rotating. That still might not prove Earth is rotating, because if the pendulum has a tiny charge in the presence of a weak magnetic field, the magnetic field could also cause a slow precession. With all this, one can confidently conclude that the Earth is not rotating. Thank you.